students, welcome back to Algebra 1B. Today we're going to talk about solving by graphing. Graphing in quotes because we're going to solve by graphing without actually graphing today. We'll talk more about that later. First of all, let's look at this equation. This is one that we're familiar with. Doesn't look like it's going to be too difficult at first, but to solve by graphing, I'm going to graph two equations. One, y equals v squared minus 8v minus 9, and then another one being y equals 0. Now, the way this should work is I should have y equals 0 looking something like this, and then I should have v squared minus 8v minus 9 looking something like this, and where it crosses, those two should be my answer. And there could be two answers, it could be one answer, or it could be no answers. So let's go ahead and see if we can do some calculations to see if we can find that intersection. Now y equals 0, I don't need to do any work on that because I know exactly where it is. Y equals v squared minus 8v minus 9, I'm going to need to do a little bit of work. So of course I can always just pretend those v's are x's right now, so that way I can graph them on the x and y axis. So first thing I want to do is I want to find the axis of symmetry, formula being x equals negative b over 2a, and again instead of x I can just say v. It's the same thing. So negative b would be positive 8 divided by 2 times 1. Answer would be 4. Once I know the axis of symmetry, I can move on to finding the vertex. So I would say 4 squared minus 8 times 4 minus 9. So I know 4 squared is 16, minus 8 times 4 is 32, minus 9. 16 minus 32 is negative 16. Take away 9 is going to give me negative 25. And here is where my issue comes in. I can definitely solve this by graphing. However, I need to know exactly where they cross. And most graphs only go up to 10. So that means I'm going to have to modify my axis to count by a different number, or I'm going to have to draw a whole bunch of extra lines underneath it. Neither of those sound particularly appetizing. So what I want to do here is kind of abstract this idea and see if I can come up with a general way of solving this without having to count all those spaces. So here's what I want to do. We're going to come back to that in just a second. I want to talk about the behavior of the parent graph. So the parent graph of a quadratic function is y equals x squared. This is a graph with no horizontal or vertical shifts and no vertical stretch. So I know that the vertex is going to be at 0, 0. Now if I move to the right 1, I'm going to move up 1. And then if I move to the right 2, I'm going to move up 4 because 2 squared is 4. If I move to the right 3, I'm going to move up 9 because 3 squared is 9. And of course, now I can actually probably stop drawing the picture, but if I went up 4, we would go up 25. Just kidding. Oh my gosh, that's embarrassing. 16. And then if I went right 5, I would go up. This is going to go off the screen, but I know it's 25. And now we can get into the abstract where I don't necessarily need to draw it the same amount, but that's going to be 36. And then 7 is going to go up 49. And then 8 is going to go up 64. So I know how much it's going to be going up because the vertical movement is the horizontal movement squared. So now here's the question. If I know that my vertex is down here and the line that it's going to cross is 25 above it, can I predict how much it's going to have to move to the right. Well, this is a pretty easy one. 25 we know is 5 squared. So if it's going up 25, that means I know it's going to go to the right 5. And of course, parabolas go in both directions. So that means it's going to go right 5, but it's also going to go to the left 5. Now, let's go back and look at our equation again. So I know that the axis of symmetry is at 4. So I know that this is 4 and the vertex is at -25. So we get this point 4, -25. Well, I know that in order to reach this red 0 line to find the solution, I'm going to have to go up by 25. So, based on the behavior of the parent graph, I know that in order to go up 25, I'm going to have to move to the right by 5. So, knowing that the axis of symmetry is at 4, if I move to the right by 5, this intersection right here must be 9. Now I also know I'm going to have to move to the left 5 to get to this other one, so that means that if I started at 4 and I moved to the left 5, that this number right here would have to be -1. So my solution to this equation is v is equal to -1 or 9. Let's try something else. Now this one has a leading coefficient, which means it's going to have a vertical stretch. So one of the ways I could deal with this is to think, okay, I'm going to deal with the parent graph, but it's going to be stretched by a factor of 3. Another way of dealing with it is just to divide everything by 3 to begin with. That way I can have a regular stretchless graph. So I'm going to choose to do it that way. I'm going to divide everything by 3. That's going to give me this equation, x squared plus 4x minus 32 is equal to 0. Since I divided both sides by 3, I can just move forward past this. So doing the same thing, axis of symmetry is x equals -b over 2a. So in this case, -4 over 2 times 1, which is -2. And then the vertex is -2 in parentheses squared plus 4 times -2 minus 32. -2 squared is 4. 4 times -2 is -8 minus 32. 4 minus 8 is -4 minus 32 is -36. So I'm going to draw a generic picture over here. I know that I need to cross y equals 0. And then I have some parabola that's going to look like that. These are the two solutions that I'm looking for. I've got an axis of symmetry that passes through it. I know that axis of symmetry is -2. And I know that the vertex is -2 for the axis of symmetry and -36 for the y value. So, knowing that I'm here at -36, in order to reach 0, that means I need to go up by 36. Knowing how the behavior of the parent graph works, in order to go up 36, what number do I have to square to get 36? I know that this number here would have to be 6, because 6 times 6 is 36. So if I start here at -2 and I move to the right by 6, that means I'm going to land right here at +4. If I move to the left by 6 to get the other intersection, starting at -2 and moving to the left 6, I would get -8. So my solution to this one would be x is equal to -8 or +4 squigglies. Okay, let's crank it up just a little bit more. Okay, this one looks terrible. These numbers are big and ugly and scary. Also, this is in a completely different form than what we looked at before, but the solution to this is actually very simple. Let's move it around and make it look like the problem that we know. So all I'm going to do is the other problems that we had were already equal to 0, so I'm going to make this one equal 0. I'm going to start off by subtracting 8b squared on both sides, making sure that I subtract b squareds from b squareds. 18b squared minus 8b squared is 10b squared minus 40b is equal to 450. Again, I want it to equal 0, so I'm going to subtract 450 from both sides. There's no like terms on the other side, so I'm going to subtract 450, and it's not going to combine with any of those. 10b squared minus 40b minus 450 is equal to 0. Now this one does have a leading coefficient of 10, and I don't want that, so I'm just going to divide everything by 10, giving me b squared minus 4b minus 45 is equal to 0. Okay, now I've got a nice standard form quadratic equation, so I can go ahead and move forward. My axis of symmetry is negative b over 2a. And this is weird because I'm using b as a variable, so I kind of have to think in my head these are x's. So this would be positive 4 over 2 times 1, which would be 2. I'm going to go ahead and draw this now. Here's my 0 line, and I know that I have an axis of symmetry over here at 2. Okay, let's go ahead and find the vertex now. The vertex is 2 squared minus 4 times 2 minus 45. That would be 4 minus 8 minus 45. 4 minus 8 is negative 4, minus 45 is negative 49. So that means that this point right here is 2 negative 49. So what I need to do here is picture I've got this parabola right here, and it's going to intersect at these 2 points, and those are going to be my solutions. So what I need to do in order to reach the top, starting from the vertex going up, I would need to go up by 49. So again, I have to ask myself, with a quadratic function with no vertical stretch, how much would I have to move to the right in order to move up by 49? What number do I square in order to get 49? The answer to that is 7. 7 squared is 49. So that means if I started at 2 and I went to the right by 7, I would land on the number 9. If I started at 2 and went left 7, I would land at negative 5. So my solution to this equation is, we're using the letter b here, b is equal to negative 5 or positive 9. And we are done.